How's that? I failed year 8 visual arts, can you tell? Alright, there's a fridge, okay, and it's got water placed inside. By the way, they call the fridge 0 degrees Celsius. That's kind of interesting because you guys know probably that a fridge is not 0 degrees Celsius. Does anyone know what it really is?
I would say 3 or 4.
Yeah, it's negative 3 or 4, roughly. It tends to be 4. I'll let you have a think about why they've deliberately not made it negative 4 and how you'd have to change things if it was. Anyway, the fridge is 0 degrees. Lost my spot on the page. And what it cools is proportional to its temperature. So they're calling H the temperature. Okay, so therefore, what equation can I form? If the temperature drop is proportional to the temperature, and it's dropping, right, because things are going towards 0 degrees, then the statement I would make would be just like this, right? It would be dH on dt, right? What's it equal to? It's a decay situation, so it's negative. You're going to get whatever the constant of proportionality is, k, and it's proportional to the temperature. I think they mean H for heat, I guess. Anyway, okay. So, part A. Show that our standard equation, show that this is a solution. We've been through this before. Okay, so let's have a go. Let's do dH on dt. Just to make it so that I have an extra step in here, I tend to show the derivative like this. So I'm not actually just writing down what this is. Okay, so now I stick that out front. And that's negative kh because there's h. Okay, so therefore it satisfies the differential equation. Okay, they always start like that. Part B, find the initial temperature, or find H naught, given that the liquid is initially at 100 degrees. I'm going to kind of skip over that because I think you guys have sort of done that to death. H naught's your initial temperature, so that's 100 degrees. They're putting some boiling water. And there's my cup, that's why it's steaming, okay? After 5 minutes, the temperature has dropped to 40 degrees. So again, I'll just draw myself a little equation here that says 100 degrees to, what did I just say, 40 degrees? 40 degrees in 5 minutes. Okay, so this is what happens, this is what takes place. So what equation is going to correspond to this that will help me work out some other constants? What should I write? Here's the equation I'm working in, right? H is my changing temperature, okay? So now it's come down to 40. My H naught's 100, so I'm just going to snap that in there. And what did we say? 5 minutes. So this is e to the minus 5k. Now, I should have said right at the beginning, here, right, they state this. I'm so used to writing a Z there, okay? So keep that in mind. We're going to pull that out in a second. What do I do with this? How do I get k out of the index? I should divide, right? 40 over 100. You can do a bit of that in your head, can't you? What is it going to simplify down to? 2/5? 2/5, yeah. That's e to the negative 5k, right? So now what? I can take log of both sides, right? So I'm going to get log of 2 over 5 here. I'm going to get just the power there. So now I want k on its own, like so. And now I pause. It's always good whenever you've got situations like this, whenever you can, you think, okay, does my answer make sense as I go through? It'll help you sort of debug rather than getting to the end and have the wrong answer and have to pedal all the way back through your steps. Okay. Now, does this make sense? Does this seem like a plausible value for k? Now, it is a plausible value, but you might think there are some problems with it because I just labored over the point that k is positive, okay? Even when you've got a decay situation or a growth situation, whichever it is, this is meant to be a constant proportionality. It just tells you the speed rather than the direction of change, okay? But there is a minus sign out the front. Why is there a minus sign out the front? Okay, so logs, right, this is a bit weird, isn't it? Logs can be negative, depending on whatever is in there. Log of 2/5, this is a very small value over here. So log of 2/5 is actually negative, right? I suppose you could write it If I were to get rid of the negative, what would it look like? It'd be a fifth, come on, use your log laws, what's it going to become? 5 on 2, right? Because it's 2/5 to the power of -1, okay? You could write it like that. It just so happens because what I'm going to put it back into already has a negative there. This negative and this negative will cancel. So you actually don't gain anything by rewriting it like this, even though it's sort of nicer, okay? But just so you know, yes, it is positive. Okay? So there's my value for k. You could stick it into your calculator and get a decimal out, but there's not really much to gain there anyway because you want something exact. Part D. I think they want to know the temperature after 15 minutes. Yeah? Okay. So when... That's the temperature. So we're going to slap it into our equation here, right? We've got our value for H0. We've got our value for K. You hit play, okay? H equals H0 there, 100, right? E to the... Now, because we've got the double negative here, right, I'm going to get rid of them. So I'm going to have a fifth log 2/5 times 15. Is that right? So that's 100. I'll do a bit of tidying up here. E to the power of 3 log 2/5. You can put that into your calculator. Yeah? Yeah, of course. You can put that into your calculator, but do you remember the trick that I showed you yesterday about simplifying, getting rid of e's and logs together in order to make this just a bit simpler? How can we do this? This 3, again, using what we saw here, right? This 3 can come up into the power, right? This is really log of 2/5 cubed. Is that okay? Can you see how I've changed the position of the coefficient? So therefore it's e to the log whatever is just whatever. Okay? Which is a bit easier to put in calculator. You don't even really need to put that into calculator, do you? That's 100 times 8 on 125. Yeah? Come on, surely we... I know you don't have to do this, but use your brain. Come on, year 12, you often don't have to do sort of calculations like this. So let's give it a go. Divide by 5 gives you that. Suppose I should have done that again. That's a bit silly. 4/5. 32/5. Oh, can you do that in your head? Yes, you can. That's 6.4. Well done. Wow, my brain can still do numbers. That's incredible. Okay. Does that seem plausible? Is that a sensible answer? Yeah, I think so. I mean, we did say we were heading towards 0 degrees. It's been in there for a little while. That's some pretty cold water. Okay, great. We're done.